Hey guys, welcome to the review for Unit 15. I would want you to pause the video and actually do the review all on your own and then look through my video. That'll be great. Okay, so this is USUP. We have a test tomorrow. So let's look at the first question. So here, what do I pick my U to be? If you think about the guidelines, you pick something that's inside the parentheses. So I'm going to pick my U to be 3x to the fourth plus 2, right? So my du is going to be, let's zoom in here, 12x cubed dx, right? So see what you have and what you want to replace with. I want to replace x cubed dx, which I have it here, right? So I'm going to get rid of the 12, so I'm going to divide by 12. So this gets cancelled. So what would be my integral? I'm going to pull out the 1/12 in the front, and I'm left with u to the 7th du. So the integral of u to the 7 is u to the 8th over 8, and I have that 1/12 from the front plus c. So don't forget your plus c, guys. 12 times 8 is 96. Substitute back your u in. Your u was 3x to the 4th plus 2 to the 8th power over 96 plus c. Okay, number 2. So here, another indefinite integral. So what do you pick? So when you have something in the denominator and inside the parentheses. So I'm going to pick my u to be 3x squared plus 2. So my du is going to be 6x dx. And look here, what do I have? I have 6x dx, and what do I want to replace it with? Replace x dx. So I want to get rid of my 6, divide by 6, divide by 6. So I'm going to pull out this 1/6. So this would be 1 over u cubed du, right? So I'm going to rewrite that as 1/6 u to the negative 3rd du. So this would be 1 over 6, u to the negative 3 is u to the negative 2, because we're adding 1 over negative 2. So if you simplify that, that would be negative 12, negative 1/12. Negative 1/12, I'm going to substitute back my u, or I'm going to move this, plus c. Don't forget the plus c. And substitute back your u, which would be negative 1 over 12. U is 3x squared plus 2 squared plus c. So that is your answer. Okay. Then the next one. Whenever you have a trig function, you try to pick the inside of the trig function as your u. If you had multiple trig functions, composite trig functions, then you might pick the whole trig function. But since you just have one trig function, I'm going to pick the inside to be u. So my u is going to be 1 minus x to the 6th. So my du is going to be negative 6x to the 5th dx, right? So again, look here, what do I have? I'm going to replace 6x, x to the 5th, and dx with x to the 5th and dx. So what do I want to get rid of? I want to get rid of my negative 6. So divide by negative 6. So I'm going to substitute that back in. I'm going to pull out the negative 6. I have sine of u du, right? What is the integral of sine of u? It is negative cosine, so two negatives make it positive, so it'll be 1 over 6 cosine of u plus c. Substitute your u back in, 1/6 cosine 1 minus x to the 6th plus c. Okay, so now this is our first of our definite integrals. So here we do everything as we are supposed to do, right? One thing you need to remember is that these are your x bounds. So you cannot, when you do your substitution, you cannot use these bounds. So what am I going to pick my u to be here? I'm going to pick something that's inside the parentheses. So u would be 1 plus 1 over x. So my du is going to be, I'm going to rewrite this as 1 over x can be written as x to the negative 1. So derivative of 1 is 0. This would be negative 1 x to the negative 2 dx. If I simplify that, that would be negative 1 over x squared dx, right? But look what you have and what you want to replace. I want to replace my 1 over x squared dx. So I have that negative in there, right? So I'm going to divide by negative. So this would cancel out, right? So let's replace it. So I'm not going to do the bounds for now. I'm just going to write in terms of u and then do the bounds in a minute. So this would be 1 plus 1 over x is my u cube, right? I'm going to pull out the negative du. Now for the bounds, what you do is you take these bounds and you substitute in for x, and that would give you your u. So if I do 1 plus, if I substitute into 1 half, right? This would be 3 halves. And if I substitute in 1, 1 plus 1 is 2. So this would be, I'm just going to show you the work, 1 plus 1 over 1, which is just 1, which is 2. So here, what do I have? This is 3 halves. I'm going to actually change, this is 3 halves, and this is 2. If you look closely, you will see that, the bounds are actually the smaller numbers at the top and the bigger numbers at the bottom. So you're going to rearrange it and negate it. So these negative would get rid of. So you have 3 halves to u cube du. Now take the integral of u cube, which is u to the 4th over 4, and I'm going to bound it from 3 halves to 2. I'm not going to write the plus c because you're bounding it, right? It's a definite integral. So now all you need to do is when you have the bounds, you do the upper bound minus the lower bound. So my upper bound is 2, so I'm going to do 2 to the 4th over 4 minus 3 halves to the 4th over 4. So this would become actually 2 to the 4th is 16 over 4 minus 3 halves would be 81 over 16 times 4 is 64. So 81 over 64, right? And I can just, if I do the math, this I can just simplify it. So I'm just 16 times, it would be 16 to 56, 256 minus 81 over 64, which would be 175 over 64, right? Okay, so the next page. Oops. So here, what would you pick your u to be? Would you pick it to be secant square x, or would you pick it to be tangent x? Think about it, right? If I pick secant square x, the derivative of secant x is secant x tan x. I don't have that extra secant x, so the better option would be to pick your u to be tangent x. So tan x, so du is going to be what? The derivative of tangent is secant square x dx. So see, I'm going to replace this with this. So that's pretty straightforward. So this would be, this is a very straightforward question. Square root of u du, square root of u is same thing as u to the 1/2 power. So 1/2 plus 1 is 3 halves over 3 halves plus c. Dividing by 3 halves is same thing as multiplying by 2/3 plus c. Substitute back your u. Your u is 2/3 tangent x to the 3/2 power plus c. Number 6. So for here, we're going to pick a u to be the exponent of e. So the exponent of e is x cubed. So take your derivative. Du is going to be 3x squared dx. So if we check, I have x squared dx here. I have x squared dx here. I want to get rid of the 3, so I'm going to divide by 3. this cancels out. So I'm going to replace this. I'm going to rewrite this integral in terms of u. I'm going to pull out the 1/3 e to the u du. E to the u is just e to the u plus c. Substitute back your u in, which was x cubed plus c. Number 7, it's a definite integral question, and I am going to pick my u first. So u is going to be something in the denominator and under the radical. So it's going to be 1 minus cosine 2x. So my derivative of that is derivative 1 is 0. Derivative of cosine is negative sign. So negative cosine would be positive sign, right? So this would be 2 times the derivative of the inside. So 2 sine 2x dx. So now let's check. What do I have? I have sine 2x dx. I'm just going to try sine 2x dx. So I have sine 2x dx. I want to get rid of the 2, so I'm going to divide by 2. So I'm left with what? Let's set this up. Be careful. This is a definite integral. These bounds are your x bounds. You cannot put them in for your u. Okay? We're going to find our u bounds after we do the substitution. So this would be sine 2x dx is just, I'm going to pull out the 1/2 du, and it's going to be 1 over square root of u. Right? So now let's find our bounds. So I'm going to find my bounds in here. I'm going to substitute my x with my x bounds, and that would give me my u bounds. So I'm going to start with pi. So 1 minus cosine of 2 pi. Cosine of 2 pi is 0. So 1 minus 0 is just, oh no, cosine of 2 pi is 1. 1 minus 1 is 0. I was thinking backwards. Then the other one is 1 minus cosine of 0. Cosine of 0 is what? 1. So 1 minus 1 is 0. So your bounds are the same. What happens when your bounds are the same? The area under the curve is 0. So you don't even have to do the rest of the work. It is going to be 0. Okay? So the next one. Here again, what would you pick your u to be? Something that's in the denominator under the radical. So my u is going to be t to the 4th minus 5. Du is going to be 4t cubed. The derivative of 5 is 0. dt. Right? Again, check what you have and what you want to replace with. I want to replace my 2t cubed dt. So I have t cubed dt. I want to get rid of my 4. So what I'll do is divide by 4. And I'm left with, so let's substitute in the integral. I'm going to pull out the 1/4. The integral t cubed dt will be replaced by du. And cube root, or I can write u to the 1/3 power. So I'm going to rewrite this before I take the integral. It will be u to the negative 1/3 du. Now the integral of u to the 1/3 would be u 1/3, negative 1/3 plus 1 is u to the 2/3 and divided by 2/3. Dividing by u 2/3 is what? Multiplying by 3/2. So this is going to be 3 over 8. Substitute back your u, t to the 4th minus 5, 2/3 plus c. Number 9. So again, I'm going to pick my u to be something that's inside the radical, so which would be u is 7x squared minus 1. So du is going to be 7 times 2 is 14. X derivative of 1 is 0. Oops. dx. Yes, again, check what you have. You have 2x dx. So I'm going to divide by what? 7. So I'm left with what? Just 2 here. So 2x dx will be replaced by 1 over 7 du. So I'm going to set up my integral. I'm going to pull out my 1/7, and this would be square root of u du. Right? So now just rewrite square root of u as u to the 1/2 power, and the integral of u to the 1/2 is u to the 3/2 over 3/2 plus c. dividing by 3/2 is same thing as multiplying by 2/3. So this is going to be 2/21 u to the 3/2 plus c. Next one, again, it's very similar to the previous one. You're going to pick your u to be 6 minus 3t to the 4th. Du is going to be, the derivative of 6 is 0, and this would be negative 12t cubed, right? dt. Now see what you have. I have t cubed, I have 1/2 t cubed dt. So I want to rewrite this as 1/2, so I'm going to divide by what? 24. Either you can do that or just pull out the 1/2 in the question itself. So I'm going to do I want to divide by actually negative 24. So divide by negative 24. So I'm left with what? 1/2. This cancels out. So I have 1/2 t cubed dt would replace my negative 1/24, and then I have u to the 1/4 power du, right? So now what is u to the 1/4? This would be negative 1/24. U to the 1/4 plus 1 would be u to the 5/4 over 5/4 plus c. Dividing by 5/4 is same thing as multiplying by 4/3. So if I multiply this by 4/5 plus c, this cancels out. 4 goes into 24 6 times. So I have negative 1/30. Substitute back your u in, which is 6 minus 3t to the 4th 5/4 plus c. Okay, so here we have a situation. What do we pick? Do I pick something to be inside the parentheses, or do I pick my exponent of u? Again, I always say, try. If you are not sure, try one, move with it. If it works, great. If it did not, then you know you had to try the other option. Since e is there, I'm going to try to I'm going to say my u is equal to the exponent of e, which is negative x squared minus x. So du is going to be negative 2x minus 1 dx, right? So I want actually 2x plus 1. So what would I do? I'm going to factor out my negative, and I'm left with 2x plus 1 dx. So again, see, what do I have? What I want to replace with? I want to replace my 2x plus 1 dx. I'm going to highlight it. I have 2x plus 1 dx, but I have that negative, so I'm going to divide by negative 1, and I get that. So now let's rewrite this. Okay, again, I'm going to highlight this. These bounds are your x bounds. We're writing it in terms of u, so we cannot use those bounds. So let's first write down the integral, and then we'll determine our bounds. So e to the u, and I'm going to pull out the negative du. Now let's determine the bounds. So I'm going to substitute in 4 for here. So it'll be negative 4 squared minus 4. Negative 4 squared is 16. So that would be negative 16 minus 4 is negative 20. And then the other one is 0. That would be just 0, because it's negative 0 squared minus 0, which would give me my 0. So your bounds are, your lower bound is 0 and your upper bound is negative 20, right, which we saw here. Now if your bounds are not in the right order, so what am I going to do is I'm going to switch them. So this would make it positive, so the negative and the negative cancel out, so my new bounds are going to be negative 20 to 0 e to the u du. The integral of e to the u is just e to the u, and I'm going to bound it from negative 20 to 0. So I'm going to just substitute in e to the negative 20, upper bound minus lower bound. Oh, I did the lower bound first. So e to the 0 minus e to the negative 20. Right? E to the 0, anything to the 0 power is 1, and this would be 1 over e to the 20. Okay, And then I think this is the oh, we have one more page to go. Sorry about that. So here, what would I pick? If this helps, I want to rewrite this as ln of x to the 5th power over 4x 1 over a. These bounds are again your x bounds, so be careful. So what do I pick my u to be? I'm going to pick my u to be ln of x. So my du is going to be 1 over x dx. So again, I have 1 over x dx. I have that extra 4. So I'm going to actually multiply by what? 4 on both sides. So if I multiply by 4, actually 1/4, not 4, 1/4, because I want the 4 in the denominator. So it'll be 4. So 1 over 4x dx will get replaced by 1 over 4 du. So let's do that. So I'm going to set up my integral. We'll do the bounds in a bit. So it's going to be, I'm going to pull out the 1/4. ln of x is u to the 5th, and dx over x is going to get replaced by du. Right? So let's do the bounds. So my bounds will be, if I substitute in e, ln of e is 1. And if I substitute in 1, ln of 1 is 0. So my bounds are 0 to 1. They are the right order, so I don't have to switch them. So u to the 5th is just, the integral of u to the 5th is u to the 6th over 6. I'm going to bound it from 0 to 1. So I'm going to substitute in, I don't have to substitute back my x in, remember, because we already determined my u bounds. I'm no more using the x bounds, which were 1 and e, right? So I'm going to do the top bound minus the bottom. So 1/4 1 to the 6th over 6 minus, I can rewrite it as actually 24. This would be just 0. So this is 1 over 24. And then last page. So here, what would I pick my u to be? So you have cotangent squared theta and cosecant squared theta. So think about it. If I pick cosecant squared or cosecant theta to be my u, my du is going to be cosecant theta cotangent theta, which I kind of don't need. I don't have an extra cosecant. So I'll pick my cotangent to be u. So my u is cotangent theta. So du is going to be negative cosecant square theta, d theta, right? So now look what you have. You already have cosecant square d theta. I just want to get rid of the negative. So I'm going to divide both sides by negative. That'll get rid of that. Now let's set this up. This is going to, I'm going to pull out the negative. Cotangent square is just your u squared. And this is just u. So u squared is what? The integral of u squared is negative u cubed over 3 plus c, which is going to be, substitute back your u in, cotangent theta cubed over 3 plus c. Or you can choose to write it as negative cotangent cubed theta over 3 plus c. Totally your call. Both are acceptable answers. Okay, number 14. Again, your bounds or your x bounds, if you're using u substitution, you're going to find your u bounds. So your u is going to be 4 minus x squared. So your du is going to be negative 2x dx. So look, I have x dx. I don't need the negative 2, so I'm going to divide by negative 2. So let's set this up. So this would be, I'm going to pull out the negative 1/2, and I'm left with square root of u, and x dx got replaced with du. Right? Now let's determine the bounds. So if I substitute in 4 minus rad 3 squared, which would be 4 minus 3 is 1, 4 minus 0 rad 0 squared, which is 4. So my upper bound is 1 and my lower bound is 4. Again, the bounds are switched, so I am going to negate it. So I will have positive 1/2, and now my lower number will go at the bottom and the bigger number on the top. square root of u du. Square root of u is same thing as u to the 1/2. So the integral of u to the 1/2 is u to the 3/2 over 3/2. Right? And I'm going to bound it from 1 to 4. No plus c in here. Please remember that, right? And you don't have to substitute your u with your x because we already found we're working with the u bounds, not our x bounds. So here again, this would just be 1/3 because dividing by 3/2 is same thing as multiplying by 2/3. The 2's cancel out. So you're left with u to the 3/2 over 3. So I am going to substitute in 4 to the 3/2 over 3 minus 1 to the 3/2 over 3. So let's do this. So you do the square root. Square root of 4 is 2. 2 cube is 8. So you get 8 over 3 minus 1 to any power is just 1. 8 minus 1 is 7 over 3. Okay. So here, if you identify the pattern, just think about it. What quantity squared would give me 36x squared? It would be 6x to the second. So I'm going to rewrite this as 1 over 1 plus 6x to the second, right? So what would I pick my u to be? I'm going to pick my u to be 6x. So du is going to be 6 dx. I just need my dx, so I'm going to divide by 6. And this cancels. So let's rewrite this. This would be 1 over 1 plus u square, and I'm going to pull out the 1/6 du. Right? Look at this. Whose derivative gives me 1 over 1 plus u square? It is arctan. So it's going to be 1/6 arctan of u plus c. So substitute back your u. So your u was 1 over 6 arctan of 6x plus c. Okay, the last question of our review lesson. So again, what would you pick your u to be? I'm going to pick something that's in the denominator and under the radical. So u is 2x cubed plus 9. So du is going to be 6x squared dx. But I have only 3x squared, so what would I do? I am going to divide it by 2. So if I divide by 2, I'm left with what? 3x squared dx. So let's set up the integral. It's an indefinite integral, so I don't have any bounds. So this is going to be 1 over square root of u, right? And I'm going to pull out the 1/2 du. Yes. So now what am I going to do with this is I'm going to rewrite it as u to the negative 1/2 du, and the integral of u to the negative 1/2 is just u to the 1/2 over 1/2 plus c. So dividing by 1/2 is same thing as dividing by 1/2 is same thing as multiplying by 2. So the 2's actually will cancel out, and you're left with u to the 1/2 plus c. Substitute back your u in, and that is 2x cubed plus 9 to the 1/2, which is same thing as square root of c. So that's your final answer. So we kind of did all the review, guys. I hope it helped, and if you still have any questions, feel free to reach out. You have the test tomorrow. Good luck.